Let's solve another question. So it says that Stephen swims back and forth along a straight path on a 50-meter long pool for 90 seconds. Stephen's velocity is modeled by the following equation, where t is measured in seconds and the velocity is measured in meters per second. Find all the times in the interval between 0 to 90 at which the Stephen changes the direction. Give the reason for each answer. Now, before dig into this question, you must know some of the basic about the velocity and acceleration. So look at the following chart, which I have especially made for you to refresh your mind that if the velocity is positive and the acceleration is also positive, means the velocity and the acceleration have the same signs, it means that they are speeding up. So whether it is positive or it is negative, so velocity and acceleration, whether they both are positive or they both are negative, it means that they are speeding up. Whereas if the velocity is positive, acceleration is negative, or vice versa, that means the velocity is negative and acceleration is positive in these two cases, so it means that the object will slow down, the speed will slow down. Now, if the velocity is either positive or negative, whereas the acceleration is 0. So remember that whenever acceleration is 0, it means that the object is moving with a constant velocity. But if the acceleration is positive or negative, whereas the velocity is 0, it means that velocity 0 means that the object is from the rest speeding up. Okay, so whether if it is positive, it means it is speeding up towards the right. If the acceleration is negative, from 0 to negative, it means that it is moving towards the left but speeding up. Okay, so if velocity and acceleration both are 0, it means that the body is at rest. So you must remember all these signs in order to give the reasons that what will happen to the object in regards of its position or displacement or the motion. So the question is, find all the times between 0 to 90 at which the Stephen changes the direction. So here I would suggest if you just go to the graphic calculator and sketch the graph. So if you just sketch the graph of the velocity, you will find a graph like that. Now go and just check what this point is. So this point between here on the x-axis there is a time, whereas in the y-axis this is the velocity. So at t equals to 56, if you calculate over here, it will be t equals to 56. So what have you seen? That from the positive direction it goes to the negative direction. Okay, so it means that the velocity changes at t equals to 56 from the positive to the negative directions. So find all the time in the interval between 0 to 90. So you can say over here at t equals to 56, the Stephen changes, the velocity of Stephen changes the direction from positive to negative. Now you might ask that why from positive to negative. So you can see that all the values that are above the x-axis can be taken as the positive, whereas all all the values that are below the x-axis. So here is the x-axis, okay? So the below the x-axis will be taken as negative. Changes the direction from positive to negative. So this is how you have to express this answer. T equals to 56, I would suggest if you write T equals to 56 seconds. Better to write the unit over here because what 56 second, minute, and since it is given as a second, so you have to write T equals to 56 seconds. Okay, in this part they are asking, find the Stephen's acceleration at the time T equals to 60 seconds. Show the setup of your calculation and indicate the units of the measure. Is Stephen speeding up or slowing down at T equals to 60 seconds? So what you have to do in order to give the reason, first of all understand what is acceleration. So just taking you back that if the displacement is given to you, you take the derivative of the displacement and you get the velocity of the moving object. If the velocity is given and you again take the derivative of the function, so it means that you get the acceleration. So keeping these notes in your mind, what you have to do that if velocity is given, you have to take the derivative of this function to get the acceleration. First of all, you have to show the setup. So only the setup, they are not asking you to take the derivative. So if you have the velocity at v of t, so you know that velocity is v of 60 you have to find. If you take the derivative of the velocity, you will get what? Acceleration. So velocity, derivative of velocity is actually equals to acceleration. So this is what you have to determine. So in order to find the derivative, you just have to show them that how you will take how you will write the setup of this equation. So you can say that derivative of the velocity function. So you can write d by dt of v of t, or you can write the whole equation. So just like the whole equation, 2.38 e to the power of negative 0.02 t sine pi t over 56 at t equals to 60 seconds. So this is your setup of the equation. Now if you will write the whole thing in your calculator, they are not asking you to solve. Just if you write this in the calculator, you will get negative 0.036. So you will get negative 0.036. Now you have to write the units of the function. So you know that the acceleration, if the speed is given as meter per second, so the velocity is given in the as meter per second. Look at this over here. So it means that the acceleration will be, the units of the acceleration will be meters per second per second. Okay, so meters per second per second, or you can write it as meter per second square as you wish. Now the second thing is Stephen speeding up or slowing down? So in order to find this, you know that the velocity and the acceleration, if they both have the same sign, it means they are speeding up. Whereas if the velocity and acceleration have the different signs on the calculation, then it means it is slowing down. So here for the acceleration, the sign is negative. So in order to confirm or in order to give the answer about the speeding up or slowing down, you can determine v of 60. So what is v of 60? So wherever you have the t, you could replace it by the 60 over here in the calculator and just check what the answer is. So if you calculate, so v of 60 is equals to negative 0.159. Negative 0.1595. So I'm writing 159. Velocity is meter per second. So comparing these two answers, comparing the signs of the acceleration and the velocity, you can say that both are negative, which shows that the Stephen is speeding up. So how can you write the answer or give the reason? You can say since okay, you can write it as at t equals to 60 seconds, both the velocity and acceleration shows negative sign, which means Stephen is speeding up. Okay, so this is how you can give the answer of this question. Here they are asking you to find the distance between Stephen's position at time t equals to 20 seconds and his position at time t equals to 80 seconds. Just now we have discussed that if the position of the graph of any object is given, you take the derivative in order to find the velocity, and then if the velocity of the function is given, you take again the derivative to find the acceleration. But if you want to go back, it means if acceleration is given and you want to determine the velocity, you have to take the antiderivative or integration. Similarly, if velocity is given and you want to find the position, it means you have to take the antiderivative of the function. So here is, you can see that in the question velocity function is given and now they are asking you to find the distance between the position at a time t equals to 20 and his position at the time t equals to 80 seconds. Show the setup of your calculation. So in order to find the distance, you can say x of t. In order to find the distance between 20 to 80 seconds, you have to take the antiderivative of velocity. That's all. Now you will go to the calculator and you just write in the calculator the same equation which is given at the top, and calculate the function, and you will find out that the answer is 28.384. At least 3 decimal places. You should give the answer till 3 decimal places. Now you are finding the distance. Although you can just leave it as it is without writing the units, and you can even write the units if you are 100% sure. For the displacement or the distance, unit will be given in meters if the velocity is given as meters per second. Now again, in the D part, they are asking you to find the total distance Stephen swims over the time interval from 0 to 90 seconds. Again, in order to find the total distance, if the velocity function is given, it means you have to integrate the function. Show the setup of your calculation. So you can say that from 0 to 90 seconds, by taking the integral of the velocity function, we can calculate the total distance. Since they are talking about the total distance, and you already remember that the graph was like this, that at 56 seconds the position of the graph was changing, right? The direction of the graph was changing from positive to negative. So in order to calculate the total distance, you have to take, or you have to calculate the area of the graph by taking the absolute value of the function. So if you will calculate it, write it in the calculator, 62.164. Now again, if you are 100% sure, about your units, then only write the units, because it's not important if they are not asking you to write the units. It's not important to write the units. Okay, so this is how we calculate the total distance. So I hope that this question understood to you, and now we will try to solve the question number 3.